Okay, so the recording is on. So yeah, alaikum assalam. So yeah, do you have any question regarding the measure 1 material? So measure 1 is on Thursday, right? Yes, okay. So any question do you have? So basically the syllabus is hardware model of microprocessor and assembly programming. Okay, so assembly programming. So assembly programming mainly it's covering. I mean it's also like according to the lab manual experiment number 2. So these two chapters basically. So hardware model of microprocessor and assembly programming. So a number system and introductory discussion, they are out of the measure 1 syllabus. So it's very basic. So we are not covering this for the exam, just for information. Okay. All right. So now, I mean, yeah, so hardware model of microprocessor, I mean, just what are the things inside the microprocessor are there. Okay, it's about that, like with different types of data registers, different types of flag bits in a flag register, when they are set, when they are reset, and data register, like AX, BX, CX, TX. So what are the application of these data registers? So these are the things actually we discussed there. And also like logical address, physical address. Okay, and what else? Yeah, so hopefully, I mean, yeah, if you, I mean, homework one and homework one and quiz one, it actually give you some information actually what sort of topics are there, and it's not all, but yeah. So study the whole chapter, whole lecture material. Okay, and in this, I mean, what are the different types of memory segments? So what are the application of these memory segments? I mean, and also stack and queue. Okay, so stack is a, I mean, yeah, stack is in a stack there. I mean, so these are the things. Yes. And assembly language, like we have discussed, like something is real instruction, something is pseudo instructions. So what is the difference between them? And different types of pseudo instruction or directives are there, right? What does this mean? Like DB, for example. So define byte. So define byte is not the whole answer. What does it mean actually? So yeah, so homework 2 and 3 is a very good example. If you study homework 2 and 3, so it actually covered the whole chapter. It's a bit longer, but it help you to get all the things here there. So yeah, this is all about that. And so, do you have anybody has exam during in the afternoon tomorrow, Monday? So we have a lab. I am thinking. So if I take the lab, so this week and next week it's online. So if I take the lab, does it conflict with your any major exam or not? That's why I'm asking, because I don't have any information about a general science course exam, you know. So anybody has exam during that time? Oh, you have IAS. Okay, okay. So what time? What time it is? And what time your exam tomorrow? Okay, check it, please. At 2. Okay, so so then actually this week, as what about the next week? Next week is okay. Next week, I mean, yeah, next week Monday is afternoon. Anybody? Do you have any exam, major exam that time? Okay, so let me know. Let me know. Then I will inform. I will if yeah. So if there is no lab tomorrow, next tomorrow, then I will make announcement. Okay. So I will make announcement on Blackboard. So just follow that one. But this week and next week it's online, so you don't have to come. Okay. So yeah. So if there is any change like no lab or anything, so I will let you know. So yeah, that's it. Okay, let us discuss more about some instruction. Like there is another chapter. It's called arithmetic and logic instruction. So arithmetic and logic is yeah. Well, already we got some instruction. They are arithmetic, like add, add. This is a arithmetic instruction, right? Addition. It is the like ADD. You can see this one is like ADD, add byte or word. For like 8-bit addition or 16-bit addition, we use this one, ADD. There is another one, it's called ADC, add byte or word with carry. So normally we do not use it, but it is a special use, so forget about it. Okay. And there is another instruction, this is also used like INC, increment. So that means add one, right? So increment by one, add byte or word, I mean increment byte or word by one. Like if I say INC, increment SI. So that means SI is a register, the value of the register will be will be one more. So and also we use AAA. So AA is ASCII adjust for addition, and these are the things normally we do not use so far. So main thing is ADD. So this one, add and increment. These two instruction we normally use. Okay, and what about the subtraction? We use the SUB sub, and we also use DEC decrement. So decrement means subtract 1, subtract by or worse by 1. Okay, so this two instruction we normally use. And what about the multiplication? We use the MUL. It is for multiplication by the words, and if it is unsigned. But if it is, I mean, integer multiplication, normally actually we use the MUL. There is another one, it's called IMUL. So mostly we use MUL. So let's say enough. But integer multiplication, because if the number is integer, I mean, there is no fraction value. Okay, so instead of MUL, we can also IMUL. It's okay. So these two. And what about the division? Division also we use DIV, and if it is an integer division like 1, 2, 3, 10, it is integer value, right? But 10.5, it is not that integer value. It is a float value, you can say, or in terms of, I mean, according to the programming. So we say it is a float value. So or decimal value. So float value. So integer, if it is an integer, then we can use IDIV, or also we can use DIV. Like, you know, we calculate the average. So average, when we calculate the average, we use this one, DIV. But we can use, if as it is integer value, we can use also IDIV. That is okay. So mostly these are the arithmetic instructions so far we used and we may use. But you know, like okay, so like for example, AX and BX, their register content is 1100 and OABC. So BX content is OABC, they are hexadecimal, and AX content is 1100. What will be the result if there is an instruction add AX comma BX? So that means the content of AX and BX, they will be added up, and the result will be saved in first operand. So first operand is AX, so that means result will be saved in AX. So that means after the instruction, what will be the AX value? AX value will be, so add these two together, it will be like C, B, B, 1, because this is 0 plus so 1, B, B, C. This one is so that means AX value will be this one, and BX value, there is no change because BX is second operand here. So it is also, we can call source operand or second operand. There is no change in second operand. So second operand BX is as it is. What was the BX value? This one. So AX value is overlap. I mean overwritten. So it was previously 1100. Now it will be 1BBC. What about the carry flag? You know, carry flag. If there is a carry out happen. So there is no carry out happen. Okay, so that means carry flag is 0. There is no change in carry flag is reset. So if it was set, it will be reset, and if it was reset, that means no change, because the carry flag will be 0 here after the instruction. Okay, so now look at here. If we use a subtraction like sub bx comma x, that means the bx minus ax, right? bx minus cx, sub bx comma cx, that means bx minus cx. Okay, so now look at here. What is bx? 1, 2, 3, 4. What is cx? 0, 1, 2, 3. So definitely bx is bigger than cx, so there will be no carry out. Okay, so carry flag is reset. Carry flag is reset. And what will be the subtraction? Subtraction, if you do the subtraction, it will be like 1, 1, 1, 1. So this is the, so bx value will be 1, 1, 1, 1. And what about the CX value? No change in CX because CS is the second operand. Okay, so it will be no change. BX value will be change, but there is no change in CX value. And what about the carry flag? So as there is no, you are subtracting a small number from a bigger number because CX is less than BX. So definitely there will be no borrow in happen. So carry flag is said, we know that carry flag is said if there is a borrow in or carry out happen in the MSB bit, like most significant bit. Okay, so and there is some logical, like AND operation or exclusive or and not. These are the things we can use them. Like if you know, for example, you know that AND operation. This is you already know it. When actually there is AND operation happen. I mean, if logical AND. So it is bitwise logical AND. Like 0 0, it will be 0 0 1 0 1 0. Only when actually it is 1 1. I mean, when the output is 1, when both are 1. And for our operation, always it is 1 except when both are 0 0. Okay, and not is very easy. A complement just say. What about the XOR? XOR is, you know, if think about the A. If A is 1, it actually complement the B. So look at here, B, when B is 0, it will be 1. When it is 1, it will be 0. But if A is 0, so it doesn't change the B. So when A is 0, B is, if B is 0, output is 0. B is 1, output is 1. So that means this is the best way to understand it. That if A is 1, so it complement the other input. If another input is 0, then output will be 1. If it is 1, then 0. Is it okay? It's called XOR. So yeah. So now look at here. Now look at here. For example, we have move AL comma 10101010. Okay. Okay, forget about this one because here, I mean, it's a little bit mistake. Okay, look at here. Move, if we have an instruction like move AL comma 01010101, like that is B for binary. So if it is the instruction, what will be the AL content? AL content will be this one, right? Because it is immediate to register 01010101. But if we make AND AL comma 000 and then 11111, what will happen? So AL is now changed. AL value is this one, okay? AL value is this one. So now if we do the logical operation AND operation of AL with this number 0001111. So one actually what happened during the AND operation? If it is 0, then whatever they are, it will be changed. It will be 000. Okay. If it is 111, so it doesn't change. It doesn't change the other bits. So other bits are as it is 10101, and but only the if this MSB 3 bit 000, that means it will must make other this 3 bit 000. Is it okay? Yeah. Now it's about the logical or AL comma 11 and then 60. So that means AL value is now this one, right? Not the previous one, because AL is changed. So AL is 00000, then 10101. Now if you do the OR operation, that means this 11, this 11, it so I mean, what about this 40? So 40 doesn't change. Sorry, 60. This 60 doesn't change the bit. Look at here. This is 60 doesn't change the bit. It is 010101. Okay. What about these two? These two bit? These two bit will be must be 1 because they are 1. Is that okay? OR operation, logical OR. And then about the XOR, look at here, XOR. So we have 4 0 and then 4 1. What will happen? So what is the latest value of AL? This one, right? This one is the latest value of AL. Okay. If we do the XOR operation of AL with for 0 0 0 0 1 1 1 1, then what will happen? So I said before that 0 doesn't change the other bit, but 1 make it complement. So look at here, this 4 bit makes this 4 bit no change. So it is 1 1 0 1. Yeah, okay. And this 4 1 make this yeah, this 4 bit complement. So it is 0 1 0 1, it will be 1 0 1 0. Is that okay? Until now, okay? All right. So now about the NOT. NOT is very simple. NOT AL. So NOT AL actually makes the things just complement. One's complement. So 1 will be 0, 0 will be 1. That's it. So this is about this. So so now let us practice this one, because this one and this one just little bit different. I mean slightly not say, I mean not fully same. So let us do this one. Okay. What will be the AL value after this this instruction AL? Okay. Alaikum salam. Huh? Oh, you are taking photo? Okay.
Yeah. You know, for this justice meeting, Dr. Alex said we should look for a time to.
Oh, okay, okay, okay. That's fine. Okay. Okay, thank you. Okay, now look at here. Move AL comma 1 0 1 0 1 0 1 0. So that means we can so it will be 1 0 1 0, then 1 0 1 0. All right. So it's very simple. Now, what about the AND operation? Now, second one, 1 0. So it is AND AL comma 0 0 0 1 1 1 1 1. So what will happen now? If like this 30 must, this MSB 30 must make whatever this bit, it must be 0 0. But 1 doesn't make change, right? So 1, it will be like 0 and then 1 0 1 0. Is that okay? Is it okay? Okay. And what about the here? Look at here, or operation. Now AL value is, yeah, the AL value change. AL value is the second one. So now AL comma 1 1 and 6 0. Okay, it's OR operation. So 1 1 makes these two bits, these two MSB this MSB 2 1 make MSB bit 1 1, and 0 doesn't make change. So 0 is 0 0 1 0 1 0. Yeah, is all right? You agree with me? Yeah. Okay. Now about the XOR operation. XOR AL comma AL is now changed. The last one, last AL is the this is the AL value. Now XOR AL comma 4041. So I said before that a 0 doesn't make the another input change, but 1 makes it complement. Okay. So that means 0 is so whatever there, it will be no change. Okay, but 1 makes it a complement. So it was 1010. Now it would be 0101. This is the AL value. Is that okay? Now about the not AL. So not is very simple. Just make it one's complement. So 0011 and 1010. Okay. Always you have to consider the AL latest value because AL is changed. So we cannot consider the previous value of AL, the first row. We have to take the immediate value of the AL. Just immediate before. What is the value of L we have to consider. Yeah, so this is about like logical operation. So like logical and logical or logical XOR, logical not, these are the things. And also like so masking bit means actually to make yeah, these are the instruction you also got it in homework solution. So just yeah, yeah, just follow that one. Okay, and now it's about some logical instruction is shift instruction. So shift instruction, during the shift operation, shift can be like shift logical left, SHL, shift logical left. And but there is another instruction is called shift logical right, SHR. And other type of shifting operation is called shift arithmetic left and shift arithmetic right, SAL and SAR. Okay, what are the difference between them? I will see one by one. So shift logical right and shift So for example, AX value is 0001, 001, and then 00011, 0100. So it's 16 bit, okay. So now what happen if it is said shift logical left AX comma 1. So that means every bit of AX will be 1 bit shifted left. So what will happen? This 0 will come here, this 0 will come here. Is everything is changed, everything is 1 bit shift. What happened this 0? It will come to the carry flag. It will come to the carry flag, and yeah, that's it. But what about this empty bit? Because this bit actually this 0 is shifted here. This 0 is shifted here. What about this empty bit? Empty bit will be filled up with 0. That's the thing. So that means during the shift shift operation, logical shift operation, the value of the value change, or yeah, definitely value will be changed. But what I mean, the number of 1 and 0 is changed now because all the empty bit is filled up to 0 by default. I mean, this is the rules. So that means the number of 1 or 0, it will not be same always before and after. But during the rotation, it is same. Number of 1 and 0. We will see it. Okay. So now it is again I am saying that 1 bit logical shift. It means that 1 bit logical shift. So every bit will move to the left 1 bit. So this 0 will move here, this 0 will move here, and so on. But what about this MSB bit? It will come to the carry flag. And what about the LSB bit? LSB bit, it will be filled up with 0 because it becomes empty. It will be 0. But if it is like what will be the shift right? Shift logical shift right AX comma CL, and if CL is 2, that means 2 bit right shifting. So 2 bit right shifting, okay, start from here, from MSB. So 2 bit shift right shifting, so it will come up here 2 bit, okay. 1 2, it will come up here, and then everything will move on, and this one will come here. But what about this 2 bit? Okay, this one will be out first, and then this 0, right? So this 0, the last bit that is out, it will fill up the carry flag. And what about the empty bit? Empty bit will be 0. All right, so now is it okay? Do you understand this one, that whatever during the shift left and shift right, logical shift left and logical shift right, is it clear? So is that okay, other student? Is it okay for other guys? Okay, all right. So now it's about that it's called shifting left and shifting right. It may be 1 bit, it may be 2 bit. Okay, so what happened actually, summary is, during the logical shift left and right, for both cases actually the empty bit will be 0, and carry flag will be the last bit. What is out? I mean empty bit. What is the last bit that is out from out, that is out of the register? That will be the carry flag. Okay, but now what is arithmetic right, or arithmetic shift arithmetic right? Okay, what happened? Okay, let's have a look here. Shift arithmetic right ax comma cl, and if cl is 2, that means 2 shift right arithmetic. So what happened? Look at here. So start from here, this bit will, so this bit will come up here, right? 2 bit, to which right shift, and then this one will be the LSB, and this one it will be the last bit out of the register. It will be the carry flag. This is same like previously. But what about here, this empty bit, this 2 empty bit? This 2 empty bit is not always 0. It will be this MSB bit. Look at here, this 0 is coming up here, and also it will fill up this 2. You get my point? Is it clear? Yeah. So if it is 1, look at here, for example, this one is 1. If it is 1, what will happen? It will, so it's 2 bit shift, so 2 bit right shift. This one will be here, right? This one will be 1. Okay, but what about these 2? During the logical shift, it will be this empty, this 2 bit empty, so they will be 0 for logical shift. But during the arithmetic shift, it will be, must be, as it is 1, they will be 1. Okay, so now it is clear. All right, so same like, if it is a arithmetic shift arithmetic left, it will be the same. Okay, now for example, let's see some example here. Move AL comma square bracket. So a square bracket means the memory location. What is the name of the memory location? For example, control register, any name. So that means it's the it means that yeah, the offset address is defined by the control this name, control flags or something like. It's a name. Doesn't matter what is the name. So that means memory location data will come to the AL, and then move CL comma. So we have to isolate the bit B3 of the byte. So B3 is, is the 8-bit data. So like Okay, let's draw it. Yeah. So this is the 8-bit data, right? So this is 0, 1, 2, 3. This one is 7, right? So we want to just only we are interested. Our point of interest is B3. So 0, 1, 2, 3. This one is B3. Okay, B3. B3. So it is, for example, X, maybe 1, maybe 0. So this is actually we want to isolate. Just only B3. Just only B3. We want to isolate. So now, I mean, what can we do? What can we do? So move CL comma 4. So for this is the CL value is 4, for example. So 04H is a hexadecimal 4 and decimal 4 is same, right? Hexadecimal 4 and decimal 4 is same. So now shift right. So what? How can we isolate it? We have to send it to the carry flag, right? So carry flag. How can we send it to the carry flag? So one of the by shifting rotation. So like for example, if you write shift logical right or shift logical left, whatever you do, what will happen? So this bit will be the last out, right? If you do the shift logical right, for example, so 4 bit, what will happen? This one will be 1, 2, 3. If you do the 3 times, it will come up here, but 4 times it will be out. So four times if you do the right shifting, so it will be out and it will fill up the carry flag. The last bit that is out of the register, it will be the carry flag. All right. So carry flag. So that means if we do the right shift AL comma 4, so because CL value is 4, then it will be out. It will be carry flag. So carry flag will be B3 then. We can take it. It may be 1, maybe 0, whatever it is. We can get it from the carry flag status because we know how to check the carry flag status. Is it clear? It's okay. Okay, so there is another instruction, a logical instruction is called rotation. So how can we do the rotation? I mean, rotation already I told you during the like number of 1 and 0, finding number of 1 and how many number of 1 in a bit, in a byte. So this is, or in a word, we already. So it is a kind of shifting, but not fully same because if look at here, for example, rotation left ax comma 1. What does it mean? So it means that left means so start from the LSB bit. So it will move here and this one will move here. This 0 is out now. So what actually this out 0, it will fill up the carry flag and also it will fill up the empty bit. So that means you can see so that if it is 1, if it is 1, it will be 1 and carry flag will be 1. If it is 0, it will, carry flag will be 0 here. So that means there is no change in number of 0 and 1 during the rotation. But during the shift cases, now it will be changed because empty bit will be default always 0 during the logical shift operation. It's okay. You get the difference between I mean shift and rotation, shift left and rotation left. Is it okay? Do you understand? Hmm? Yeah. Yes. Okay. Now look at here. Shift right. shift right AX comma CL, and CL is 4, for example. So that means 4-bit rotation right. So for right cases start from MSB. So 4-bit. So 1, 2, 3, 4. So it means from here. So this 0 will come here. Everything will be changed, and here also this everything. So this 0, this 1 will come up here. Okay, that's it. What about this bit? They are out now. So 0 will be out first. Then so this 0 will out first, and then fill up carry flag, and then also this this bit MSB bit, and then next this 0 will out first, then it will fill up the 0 flag and the MSB bit. Everything will shift it. So what will happen? So look at here, this 0 is coming up here, and then 0, then 1, and then last 0 is this one. Last 0 is this one that is out. So it will be here. It will be the MSB bit and carry flag. That's it. So that means you can see that number of 1 and 0, there is no change in number of 1 and 0 in the during the rotation case. Left or right, whatever it is, during the rotation case, no change. So it is a 16-bit. Okay, I am giving you the example of 8-bit. That will be more easier. Okay, let's see. So until now it's okay, right? Rotation left, rotation right, 1-bit or 4-bit or 2-bit, whatever it is. What is the process? Okay, this is the last page. Okay, I am giving you some example. For example, this is the AL register value. It may be something, it may be like 1 0 1 1 0 0 1 1. So now if I say that what will happen if it is like rotation ROR, rotation right AL, 2. So that means 2-bit rotation right. So what will happen during the rotation, right rotation? During the right rotation, we start from MSB bit, right? We start from MSB bit. So 2-bit rotation. So that means this one will come up here, right? This one will move to 2-bit 1, 2. So it moves from here for 1-bit rotation, right? And then 2-bit that will have. So then this 0 will come up here. And then this 1, and then this 1, and then this G. Okay, so then this 0, this 0. Okay, now look at here, what will happen? This one will be out first, and it will fill up here. Okay, so what will happen? So that means this one, so it will come up here, and then this one. Okay, so this one will the last come out, and it will fill up this one, and also the carry flag. Also the carry flag. carry flag, it will be also 1. Is that okay? Carry flag will be 1. Is it clear? Yes. So now what happened if I say, so now that means what is the AL value? AL value is this one. Now if I say rotation left, rotation left AL comma 2. So 2-bit rotation left. So during the left rotation, we have to, start from LSB because it's left rotation, right? Left rotation. So that means this 0, 1, 2, it will come up here. Then this 0, then this 1, then 1, then 0, and then 1. Okay, what happened here? This one will be out first and then this one. So that means it will come up here, and then the last one is this one, right? It will be out, and it will make the carry flag also 1. Carry flag will be 1. Carry flag will be 1. Is that okay? So now look at here. So it becomes the original value, the previous value, because 2-bit we make the 2-bit right rotation and 2-bit left rotation. There is no change because during the rotation case, no change in number of ones and zeros. So yeah, that's it. So that's why during 1-bit, 2-bit right rotation and then 2-bit left rotation, you will back to the original value. Yeah. So 1011 0011, and carry flag is now 1. So now carry flag. So what is the status of carry flag? Is it clear, right? So basically, there is another rotation, rotation left and rotation right through carry. Actually, through carry we normally do not use it. That's why I'm not giving you this example. So when actually we use, but mostly we do not use it. So rotation left and rotation right. That's it. Not through carry. RCL means through carry. Rotate, left or right through carry. If there is in the middle C. So this is. So then whatever the shift. Okay, let me give you example of shifting. Then it will be clear again. Shift. A logical shift left and logical shift right. So giving you the example, then we'll finish it. So AL, for example, this one, 0 1 0 1 0 0 1 1. Okay, for example, this is the AL value. Now what happened if it is like shift right, shift logical right? Okay, shift logical right, AL 2. So right shift. Okay, so it start from MSB. Okay, so this 0 will move 1 2. So so that means it will be this 0 1 0 1, then 0, 0. What will happen to this empty bit? We have a 2 empty bit, and what about the carry flag also? Carry flag here. So carry flag, this one will be out, and then this one will be out, right? So the last one, it will be, last bit that is actually out from here, it will be the carry flag. Okay, so carry flag is this one, it will be 1. And what about this empty bit? Empty bit is by default 0. Yeah, 0. So that means, look at here. Now actually 0 1 0 1 0 0 1 1. It is like actually what was it? But after the logical shift right, 2 bit logical shift right, it becomes the different value, and you can see the number of 1 and 0 are not same. So yeah, this is about the But now if I say that shift, so only what are the things is like we can take the bit, a specific bit, like for example bit number 1 or bit number 0 1 2 3. For example, if like this exercise, if we want to pick up a particular bit, we can do it, because it will be we can take it from the carry flag. This is the only thing, but otherwise actually the number of 1 and 0 we cannot keep it same. What about the left, logical shift left, AL, comma 2. So AL value is now the immediate one. Immediate one is this line. Okay, if for example we do the logical shift left, logical shift left, so what will happen? Start from the LSB bit. So this 0 will move 1 to here. So left, then 0 0 1 0, and then again 1, and then 0. Okay, so look at here. So this 0 move 1 and 2 bit, and everything is moved 2 bit. So then what about here? So they will be out, right? This 2 bit will be out. So this 0 will be out first, and then this 0. So what will be the carry flag? Carry flag will be what? 0, right? The last out bit will fill up the carry flag. Carry flag will be 0. Okay, and what about these 2 empty bit? They will be must be 1 or 0. 1 or 0 empty bit. Hmm? 0, yes. This 0 and 0. Okay, so now it will be this one. So look at here. So we do not get back. So we perform the 2 bit shift right and 2 bit shift left, but we do not we cannot back to the original value, because it is changed, because number of 1 and 0 definitely will be changed. So it is like that, you can see. So but during the rotation it doesn't happen, number of 1 and 0, no change in number of 1 and 0. So hopefully it is clear, right? Is it okay so far? Yes, okay. So this is about the logic instruction, logical shift, arithmetic instruction and logical instruction. Hopefully it is okay. And then so that's all for today. Because I have a major exam from 12 o'clock. I have to yeah, upload the question on the Blackboard and so on. So I hope, because I mean, do you have any question? I mean, I'm not going new topics before the major. So if you have any question, you can ask me, or otherwise I will leave, because I have to yeah, upload the question on the Blackboard and do some work. Okay. Any question do you have regarding the major? No question. All right.